Hi, in this unit we're going to be looking at Pythagoras' theorem. So Pythagoras' theorem links together the three sides of a right angle triangle. So with a right angle triangle we've got the hypotenuse, which is opposite the right angle, and then we're going to just refer to these two other sides as legs. Okay, so these are the legs that make up the right angle triangle. So in a right angle triangle we can say that the hypotenuse, so c squared, is equal to a squared plus b squared. Okay, so we can use this is Pythagoras' theorem. We can use this equation in order to solve for an unknown side length. So if we know one side length, we can find, if we know two side lengths, we can find the other side length. So a nice graphical representation of Pythagoras' theorem is this. So we can see that if we have a side length, we have a right angle triangle, we have a side length. If we square it, and then we square the other leg, then these two squares actually equal the size of this square. So a squared plus b squared is equal to c squared. So if we cut up these two squares, they'd fit perfectly into this square. So using c squared equals a squared plus b squared, so this is Pythagoras' theorem, we can find either, so we've got two legs and we're going to find the hypotenuse, or we've got a leg and a hypotenuse and we can find another leg. So the way that we use the formula is, when we're finding the hypotenuse, okay, so we're trying to find the hypotenuse, so we've got c, so our a and our b don't matter which one we label as our a and our b, but c is always the hypotenuse and it's always opposite the right angle. So c squared is equal to a squared plus b squared. Now, so therefore c squared is equal to a is 2, so 2 squared plus 3 squared. So therefore c squared is equal to 2 squared, so 2 squared is 2 times 2, which is 4, plus 3 squared, which is 3 times 3, which is 9. So therefore c squared is equal to 13. Now, in order to get c by itself, because we want to just find the length c, we need to get rid of the square sign, and the opposite of squaring something is square rooting something. So if we square root both sides, we're going to be left with c is equal to square root of 13. And that's in centimeters. Now the textbook leaves it in, this is called surd or radical form, so leaving it at square roots. But a lot of the time, in real life, if you're actually trying to work out the side length of a triangle, what is root 13? What actually is that number? So I want you to get into the habit of actually calculating what root 13 is. So on your calculator, square root of 13, and I want you to generally just round it to 2 decimal places. So root 13 is 3.60555, and now that's going to round to 2 decimal places. That 5 is going to round the 0 up to a 1. So to 2 decimal places, c is equal to 3.61 centimeters. So that gives us more of an idea of exactly what root 13 is. It's 3.61 centimeters. Hard to visualize what square root 13 is. So now, finding a leg, pretty much the same. So we're going to have c squared equals a squared plus b squared. But when finding a leg, I actually want you to leave it. So let's say that this is our a, this is our b, and this is our c. It doesn't matter which side we label a and our b out of our legs, but the hypotenuse is always c. So now I'm going to get you, whenever you're finding a leg, write it as a squared plus b squared equals c squared, because we're going to have to rearrange this equation. So do we know a? No, we don't. So a we're going to leave as a squared. B squared is 5 squared, and that's equal to c squared, which is 6 squared. So a squared plus 25, 5 squared is 5 times 5, which is 25, is equal to 6 squared, which is 36. Now, in order to solve for a squared, we need to remove 25. So we've got plus 25, so we need to do the opposite, which is taking 25. So we're going to take 25 from both sides. They cancel out, and we're left with a squared is equal to, so 36 take 25 is 11. Now we've got a squared equals 11, so we need to do the opposite of squaring. So we're going to square root both sides, and we're going to be left with a is equal to root 11. Now the square root of 11, so the textbook's usually going to leave it in this form, but I want you to actually calculate what the square root of 11 is and round it to 2 decimal places. So it's equal to 3.3166, and so this 6 to 2 decimal places, this 6 rounds the 1 up. So it's equal to 3.32, and it's in centimeters again. So just a quick recap, when you're trying to, you can use Pythagoras' theorem, which is c squared is equal to a squared plus b squared. C is always the hypotenuse. And when finding a hypotenuse, you're going to start with c squared on the left-hand side to make the rearranging easier. Hypotenuse, you don't need to do any rearranging, it comes out nicely. When you're trying to find a leg, so one of the other sides, not the hypotenuse, start with a squared plus b squared on the left-hand side. And it's going to make the rearranging easier. Thanks.